Hello, my name is Zoe Turner, and this is my lab for oscillations. And in this lab, the purpose is to observe and measure the motion of mass swinging at an arc while oscillating on a spring, using the observations to create a model which follows the motion and measures the energy changes as well. As a result, we find the potential kinetic energies were in opposite trends, and that total energy always equaled zero. So to even do this lab, we have to do Newton's second law, and we have to take in consideration of the forces of F spring plus F gravity equals the F net. And we also have to take in consideration that absolute value of F net equals K times S plus mass times gravity, which is the F spring and F gravity. Furthermore, we have to use energy, and we understand that the system is the mass in the spring and the earth, which would mean that there is no work or energy change. And as you can see below, the equations for kinetic, universal spring, and universal gravity. So in this observed data, I found my initial position was at negative 0.1, and in the y direction it was at negative 0.6. My initial velocity is 0 because it starts at rest, and the mass of the object was 0.402. And it oscillated every 1.5 seconds. In my observed data, I found the spring constant was 6.4, the gravitational constant is 9.8, of course, and the F net is the force of the spring plus the force of gravity. And the relaxed length of the spring I found was 0.089. And you can see in the code below where I found the K, universal gravitational, universal spring, and energy, or total energy. More so into the code, looking towards more to the bottom, this is how I've calculated the energy changes. And this is important to note because we needed to find kinetic and universal gravitational to even get to the total energy that's changing. More into graphs. This is the ending graph that I got. As you can see, the orange line is the total change in the system, which is 0, because the energy in the system equals energy in the surroundings, and there is no energy in the surroundings. And you can see my model on right next to this graph, and it just shows the spring throughout the entire oscillations. Here shows what the discrepancy is throughout the oscillations. As you can see, a lot of the lines don't add up with each other because we do not take into account of drag force. And so what if, for our model system, is the energy principle satisfied? Yes. And like I said before, the energy in the system has to equal the energy in the surroundings. And since there's no energy in surroundings, the total change is 0, which is the orange line. So what if, when using data in the tracker to make two separate estimates of oscillation periods and the x and y coordinate, and then we just have to compare the two estimates and discuss. So in the x coordinate, I got 1.6 seconds, and in the y coordinate, I got 1.5 seconds. So using the data I found on the x-axis, it would create more discrepancy with the k constant. And so this is why y needs to be used, because the spring is in the y direction. So it would make more sense to use the y's discrepancy than the x. Thank you for watching my video. The link to my glow strip